Okay, so we are continuing on with partitioning a segment. I just didn't want to try to have to talk so fast that I ran out of time. So what we're looking at is the same thing that we just did with part one, except for this time we can't do it graphically because we're not going to have very nice numbers. So we're going to start off by looking at, first off, how many total parts do we have? If we have a ratio of 1 to 6, that's one part on one side, 6 parts on the other. So we have a total of 7 parts. Okay, now we are going from point B to point A. So we're going B to A, which means that this is B and this is A. Okay, so let's take a look real quick here. Again, the first thing that I want to do is I want to find the length of my horizontal and vertical change. Let me get this written here. Okay, so the same thing that we started off with last time. How far are we moving left to right? How far are we moving up to down to get from A to B? So the next thing I'm going to do is go ahead and label my points. So A is going to be at the point -4, 5, and B is going to be at the point 6, -2. So now, when we're finding this horizontal and vertical distance change, we are going to, this is our absolute value. To find that horizontal change, we are looking to see, okay, from here to here, what's the difference? So it's going to be the absolute value of -4 minus 6, which is a length of 10. Okay, then when I look at the y, I'm going to do the same thing. I'm going to do 5 minus a -2. And again, you can put these in whichever order you want. It doesn't matter. You're going to end up with the exact same thing. So I have a length of 7. All right. The next thing that I'm going to do for step 2 is to find out how far I need to move from point B to be in a ratio of 1 to 6. So my portion of my segment that I'm moving, from B, I am moving one part out of the total 7 parts. So this is the number of parts away from your point. And in this case, we are looking at B. This is the total number of parts. Okay, so we have a total of 7 parts. So we're doing 1 out of 7. The reason, again, that this is a 1 is because my ratio is 1 to 6. Okay, it will not always be a 1. If I had a ratio of 2 to 5, then I would have 2 over 7. If I had a ratio of 3 to 4, it would be 3 out of 7. Okay, so whatever this first number is here out of your total number of parts, that's what your fraction is going to be. So if we look at our x's, okay, my x length, my change in x here is a length of 10. Okay, we're going to take a 1/7 of 10, which is not a nice number, so we're just going to leave it as 10/7. And this is why we had to do this algebraically and not just graphically. All right, the next thing we're going to look at is y. Okay, y had a length of 7. I'm going to take a 1/7 of 7, which is nice, a number, just 1. All right, then the third thing that we're going to do, the third step, is we're going to find the location. Pen's going a little crazy here. Find the location of point P, and we're doing that from point B. Okay, so again, I'm going to start with writing the ordered pair for B because we're going from B to A. So B is the ordered pair 6, -2. Okay, then I'm going to bring in my 10/7 from up here and my 1 from up here. And I have to figure out, am I adding these or subtracting these or what am I doing? So from B, in order to get to my segment, I am going left and then up. Okay, so if I'm moving left, that is a negative direction. I'm going to be subtracting. If I'm moving up, that is a positive vertical direction. So I'm going to be adding in my y's. Okay, now the next thing is we can't add 6 and 10/7. Okay, so we need to make this out of 7. So 6 is 42/7. So then minus 10/7. And -2 plus 1 is just -1. So then we're going to get here and do 32 out of 7. So 32/7, comma, -1. I want to see you write this number down because it is the most accurate. I don't want you just rounding off out into nowhere, no man's land. Okay. So we don't want to truncate our decimals. I want you to leave it here. But in order for you to plot it on the number line, you may want to go ahead and determine what that is in decimal form. And it is about 4.5. It is a little more than 4.5. So we're going to go about 4.5 down 1 to get the location of this ordered pair. And it is on my line. So this is point P right here. So I have a section. I have one part over here, and I will have 6 parts over here. Okay. So again, questions on that, make note of it somewhere on your paper. And then I want you guys to go ahead and try this one on your own. I want you to do it algebraically first. Okay. If you like doing it graphically, that's fine. That's not a problem. This is one that it will work graphically on easily. But I want you to try it algebraically first because that is the harder method to do it. And then if you want, you can check your work with it graphically. But again, please start with the algebra first. So go ahead and pause your video now. Okay, so go ahead and check your answer here. You should have gotten -2, -1. A common mistake is to get 2 5 because instead of multiplying by 3/5, you only multiplied by 1/5. We don't do 1/5 because then that would be a ratio of 1 to 4. And we would have 1 part and then 4 parts on the other side. Okay, so we want to go 3 parts out of the total 5. So that's why we're using 3/5. Another common mistake was to do, like, especially if you flip these and you did 8 minus 7, and you said that this length was 1 instead of 15, because you didn't do 8 minus -7. So be careful. Those were some of the big key mistakes that I have seen. Okay. I also was getting questions about how to tell whether you're adding or subtracting here. I want to show you guys something real quick here. If we are looking at segments A to B. Oh, I don't want that to be dotted. Hold on. Let me fix that real quick. Okay, so I'm going to look at segments that have a positive slope and a negative slope. And if I label these as segment AB, each one of them. And A I'm going to put on the left, and B I'm going to put on the right. So if I'm going from A to B, okay, horizontally, I'm going to move in a positive direction. Vertically, I'm going to move in a positive direction. Okay, if my slope is negative of my segment horizontally, I'm still going to move in a positive direction. Vertically, now I'm going to be moving in a negative direction. Okay, then if I go from B to A with these two on the bottom here, okay, if I'm moving horizontally, I'm going to be moving left. And then vertically, we're going to be moving down. So both of those are a negative direction. If my slope's negative over here, if I'm going to my my segment here, I'm going to be moving to the left, which is a negative direction. Then we're going to be moving up, which is a positive direction. So again, any questions you have, go ahead and write those down somewhere on your notes, and then you can ask me in class later. Have a great day, guys.